Good morning, guys. I hope you are all okay in this situation. Okay. Yesterday, we have discussed the most important topic of concrete technology, that is the mixed design of concrete. We have discussed all the steps, what is the need of mixed design, why in the context of concrete technology the mixed design is necessary, and then we have discussed what are the prerequisites that we need for the mixed design of concrete. Then we discuss the steps that are involved in the mixed design of concrete. Then also we discussed the various steps and various checks that are performed for the appropriate mixed design of concrete. We have seen through our lecture in the next previous class that how to design a proper mix for the concrete, taking mineral admixtures, chemical admixtures, as well as water absorption and water free moisture of the concrete. We have considered all that, and finally we have seen that how to determine the various proportions of various materials of the concrete. So today we will see one example of mixed design. Today's example of mixed design will be based on without any admixture, chemical and mineral. So in our example today, we will discuss a concrete where no chemical or no mineral admixture is present. That means the concrete is without fly ash or GGBFS, and also the concrete is without plasticizer or super plasticizer, which are the chemical admixture. So this is the math, this is the data that we have got, that is the grade FCK M30, that is equals to the FCK, that is equals to the M30 type of cement that is given, PCC cement, maximum nominal size 20 mm, aggregate, exposure condition severe, and for RCC it has to be mentioned for RCC. Then the workability 75 mm slump, method of concrete placing non-pumpable, degree of site control very good, type of aggregate crushed angular, that is the angular aggregate, maximum cement content 450 kg per meter cube, chemical admixture no, because I have discussed that chemical and mineral admixture will be absent in this math. Specific gravity of the cement 2.88, specific gravity of the coarse aggregate 2.74, specific gravity of fine aggregate 2.65, and water absorption, coarse aggregate that, fine aggregate that, and sieve analysis report of fine aggregate as per zone 2. So the fine aggregate is at zone 2. So first we will discuss the each steps and how to determine the mixed design we will discuss now. So first, coming to the step 1. Now this is the design procedure that we have discussed in the earlier previous last class. So first, what is step 1? Calculation of the target mean strength for the mixed proportioning. Calculation of the target mean strength for the mixed proportioning. So calculation of the target mean strength, what is the formula? That is the FCK dash equals to FCK plus 1.65 S, or FCK dash equals to FCK plus X. Now so this is the two formulas that we'll use. Now from table number 1, now what is the grade designation? M, FCK is equal to 30 Newton per millimeter square, because it is M30. So if we see table number 1 of IS 10262, okay, so this is IS 10262 2009. So here from table number 2 we can we can take the value of X, that is the value of X for M30 concrete to be 6.5. So taking the value 6.5, also S from table number 2, standard deviation S from table number 2 for M30, this is 5.0. So taking the two values, putting all the values for FCK dash equals to two values, 30 into 6.5, 30 plus, this will be plus, okay, 30 plus 1.65 into 5, that is equal to 38.25, and another one is 30 plus 6.5, that is equals to X. So which value to be taken? So as per the design procedure, which value to be taken? Always the standard value, so is the higher value we have to take. So FCK dash will be 38.25 Newton per millimeter square, 38.25 Newton per millimeter square. Now coming to the check 1. So there are some checks. First check is the above values correspond to the good degree of site supervision and site control. So what is the site control degree of our math? Good. So no change is required. So site control is good. So no need for check number 1. Step number 2 is approximate air content determination. Now what is the maximum size of the aggregate? That is 20 mm. Determination now, approximate air content. Now for 20 mm aggregate, what is the percentage of the entrapped air? That is 1%. So for my nominal maximum size, air content 1% that we have taken from this chart, that is given in the chart. We can see from the IS 10262 also, that is from 20 mm, that is 1% of the air content will be provided. Next, coming to step number 3. What is step number 3? So selection of the water cement ratio, clause number 5.1. Now for the selection of the water cement ratio, we have to follow, that is, in absence of the any data, the trial water cement ratio to be taken from relationship in figure number 1. Now coming to figure number 1. What is figure number 1? There is figure number 1. Now what is the type of cement given? Type of cement is PPC. Type of cement is PPC. So you have to apply check number 2 here. So what is the check number 2 that is given? In absence of any data for cement PSC and PPC, it means Portland slag cement and Portland Pozzolana cement, the water cement ratio for 28 days compressive strength value to be taken for curve number 2. So for curve number 2, so as it is PPC given, so we will use curve number 2 from figure number 1. So this curve we will be taking the value. So what is the target mean strength FCK dash? We have got 38.25. So it will be, so now if we draw a perpendicular line from this, they consider this to be 38.25, near, this is near about 38.25, okay, near about 40. So a straight line that connects this point, this is curve number 2, and it then as parallel perpendicular line connected to that point. So if it is 0.4, it is 0.45, it may be taken as 0.42. So you are taking the water cement trial water cement ratio 0.42 as per the figure number 1. Okay, so this is the figure number 1. We have determined the trial water cement ratio. Now coming to check number 3. What does check number 3 says? The trial value of the water cement ratio shall also be less than the maximum water cement ratio for the required exposure condition. Table number 5. We do not need the table number 5 now because I have given the chart here. We can see from here also that for this is the chart given. Now for the type of concrete that we have used, that is the reinforced concrete and severe condition reinforced concrete. So what is the maximum water cement ratio for the reinforced concrete and severe condition? The maximum water cement ratio for reinforced concrete and for severe water cement ratio, that is equals to 0.45. So the maximum water cement ratio is 0.45, hence 0.43, that it is the value we have taken, 0.42 and 0.45. so it is okay then. Okay, then it is okay. So the water cement trial water cement ratio that we have selected, it is less than the maximum water cement ratio, then it is okay. Okay, so this is step number 3. Coming to step number 4. What is that? Solution. Selection of the water content and the admixture content. Now water content to be selected from table number 4 of IS 10262, which is this table. So what is the nominal maximum size of aggregate? That is 20 mm. 20 mm that I have given in the map, that is the nominal maximum size of aggregate is 20 mm. So for 20 mm, what is the water content required? That is 186. So taking the water content 186 kg. Clear? So we have got that. Now this value of water content is for angular coarse aggregate and 50 mm slab. So check number 4. Check number 4 is for the shape of the aggregate. For subangular, gravel with crushed particle and rounded gravel. So what is the type of aggregate that we have used? That is normal crushed angular. So no checks will be, no adjustment will be done here. So no adjustment, type of aggregate angular, therefore no need for any adjustment as per the check. So check number 4 is done. Coming to check number 5, that is the workability check for the workability. For slump value more than 50 mm. Now what is the slump value given here? 75 mm slump value. So for each 25 mm increase in the slump value, 3% decrease in the water content. So we have to increase. So what is the increase here? Slump value. The slump value increased by 25 mm has been increased. So for 25 mm increase, 3% water content has to be decreased. So as for 20, it is written there, for 25 mm increase, slump value to be decreased by 3%. So adjust water content for 20 mm slump value. increase in the water content, we have to increase the water content here. So increase in the water content will be 186 plus 186 by 3% of 186, that is 191.58 kg per meter cube. So this will be the adjusted water content for our case. Clear? This will be the adjusted water content for our case, which is very important. This is the check number 4. This is check number 4. Check number 5 has been done. Now coming to check number 6, very important check for the admixture. Now here in the first stage it has been specified that there is no chemical or mineral admixture, so this check number 6 will be neglected because no chemical admixture is used, therefore no need to adjust anything. So no adjustment for check 6 will be done here. Okay, no adjustment for the check 6 will be done. Next, coming to step number 5. What is step number 5? Calculation of cementitious material content. Now here there will be it has been specified in the math that there is no mineral admixture. So very much important part, that is check number 7. What is said? Check number 7 says if mineral admixture is used, then we have to apply this check number 7. So there is no mineral admixture used here. No mineral admixture, that means no cementitious material, that is GG, no granulated blast furnace slag or no fly ash has been used in this case of concrete. So no check, no adjustment. So no check 7. So check 7, as no mineral admixture is, no adjustment has to be done. So in check 7 it has been said that we have to increase the total cement content by 10%. We do not need that because no adjustment has been done. So the cement content will be by equal with that formula. Water content we have got, what is the water content that we have got? 191.58. and what is the water cement ratio that we have got? That is 0.42. so putting all the value 191.58 by 0.43, that we have got the water cement content 445.53 kg per meter cube. So this is the cement content that we have to use. That is a calculation of the cement content. So check 7, there will be no check 7 because no mineral admixture has been used. Coming to check number 8. Check number 8 says maximum cement content to be checked as per IS 456 2000 clause number 8.2.4.2. Okay, clause number 8.2.4.2. What clause number 8.2.4.2 says? That maximum cement content not including fly ash and GGBFS shall not increase by 450 kg per meter cube. So maximum cement content not including fly ash, that means the only cement content that should not increase 450 kg per meter cube. So here what is our cement content that we have calculated? 445.53 kg per meter cube. So it is less than 450 kg per meter cube, hence it is safe in maximum cement content. So this check is satisfied. Then we can proceed to check step number 6, that is the estimation of the coarse aggregate. Okay, I think up to that all the steps are clear. If you have any question, please ask the question because it is very important. Coming to step number 6, estimation of the coarse aggregate proportion. How to estimate the coarse aggregate proportion? Now from table number 5, this is the table number 5 of IS 456, which states the volume of the coarse aggregate in the volume of the coarse aggregate per unit volume of the total aggregate. That means total aggregate is, if 1 m cube total aggregate is there, so in between the 1 m cube how much volume of the coarse aggregate there will be, we have to calculate that from here. So nominal maximum size of aggregate, that is given is equal to 20 for our case, that is given is equal to 20, nominal maximum size of aggregate 20. And what is the zone? It also depends upon the zone of the fine aggregate also. So what is the zone given? The zone given is zone number 2. So for zone number 2, and maximum size of aggregate 20 mm and water cement ratio, and this is only for water cement ratio 0.5. So the value is 0.62 meter cube that we have got, that is for 20 mm, and zone number 2 we have got the maximum coarse aggregate content 0.62 meter cube, which is we have got. Now check number 9. The table is for only water cement ratio 0.5, but in our case, what is the water cement ratio that we have got? 0.43. So the water cement ratio has decreased from the specified value. So for that we have to apply some adjustment. What is the adjustment? If the water cement ratio or the water cementitious material ratio decreases by 0.05, then increase in the volume of the coarse aggregate by 1%. So what is the decrease in the water cement ratio? 0.07. So adjusted volume of the water coarse aggregate will be 0.62 plus 0.62 into 0.07. That is the adjusted extra volume that to be added, because we have to increase the volume by 1%. So by interpolation or Wikineum, if we apply here, we can get this value to be here. So adjusted volume of the coarse aggregate is equal to 0.634 here. Adjusted volume of the coarse aggregate 0.634. Now the volume of the fine aggregate will be 0.634. Now volume of the fine aggregate will be 1 minus 0.634, that is 0.366. It is the volume of the fine aggregate. That means in 1 meter cube volume of total aggregate, 0.634 is the volume of coarse aggregate and 0.366 meter cube is the volume of the fine aggregate. Now coming to check number 10, what the last check that to be applied, that is sometimes to ensure better workability, hydraulic pump system is used, that is the pumpable concrete. Now let us check if our concrete is pumpable or not. It has been said that the method of the concrete placing is non-pumpable, so there is no need for check number 10. So check number 10 can be no need, not non-pumpable concrete, so no need for any adjustment. So check number 10 can also be neglected. So throughout our study we have got the volume of the coarse aggregate and fine aggregate, and weight of the water, weight of the cement, and water cement ratio, and also the volume of the air content. Now we have to calculate that step. Now coming to the step number 7, the calculation of the mix proportion. So each formulas are given. Volume of the cement is weight of the cement by specific gravity of the cement by 1 by 1000. Putting the value, the weight of the cement is we have calculated, that is 445.653. Putting the value here, 445.53 by 2.88 is the volume of the specific gravity of the cement that is given here. So putting all the values here, we have got the volume of the cement, that is equals to 0.1547 meter cube. Volume of the fly ash or GJB is 0 because no mineral admixture has been used. Then coming to volume of the water, 191.58. Volume of specific gravity of the water is 1. Putting the value, getting 0.19158. Chemical admixture 0 because no chemical admixture, plasticizer or super plasticizer has been used. We are entrapped. That is 1% of the 1 meter cube. It says here, it says in the chart number check number 2, that is the air content that to be taken. The air content is 1% of the volume of the concrete. The volume of the concrete we are determining per meter cube, that means 1 meter cube. So 1% of 1 meter cube, that means 1% of 1 meter cube, 1% of 1 meter cube, that means 0.01 meter cube. So the total volume of the aggregate we have got. So we have got the volume of the cement, volume of the coarse aggregate, volume of the cement, volume of the water, volume of the air content. Now we have to find the total volume of the aggregate, total volume of the total aggregate in 1 meter cube of concrete. For example, if consider this is the volume, total volume of concrete, this is 1 meter cube, this is cement, this is water, this is air. So extra this portion has to be the total aggregate. So we have to first find out the total volume of the total aggregate. So dividing, subtracting the volume of the water, cement and air content from the total volume of the aggregate, we have got the total volume of the aggregate in 1 meter cube of concrete is equal to 0.64372. Therefore, from the total volume of the concrete, the mass of the coarse aggregate, we have to find out the mass of the coarse aggregate is equal to that value into the volume of the coarse aggregate that we have calculated, 0.634, that I think we have calculated 0.634. Here it is 0.634. So putting all the values here, we have got the weight of the coarse aggregate 11818.24 kg per meter cube and 624.34 kg per meter cube. So we have got all the weight of all the materials. Now coming to step number 8, if otherwise specified. So let us check if the water absorption on the free moisture is specified or not. It has been specified that the water absorption of the coarse aggregate and water absorption of the fine aggregate is given. There is no water free moisture that is given by the coarse or fine aggregate. So we have to apply the check, or we have to apply the adjustment here. Now, if So if here it has been said that the water absorption of the coarse aggregate will be x1, water absorption of fine aggregate x2, and free moisture y1 and free moisture of fine aggregate y2. Now here only the water absorption given. So x1 greater than y1 and x2 greater than y2. So here ZA has to be find out. So we have to find out ZA. We have to find out ZA. We need to find out now. ZA we have to find out. So the value of the ZA for coarse aggregate will be 0.5% because it is 0, and ZA for fine aggregate will be 1%. So this is the value of the total water absorbed by coarse aggregate, total water absorbed by fine aggregate. Now applying this formula, that is the for water absorption, applying the formula, adjusted mass of coarse and fine aggregate will be, coarse aggregate will be 1184, that is the calculated mass, divided by 1 by the ZA, that is 0.5 by 100, that is equals to 1112.68. Similarly for fine aggregate it is 618.16 because the fine aggregate weight is that, and 1% is water absorbed for the fine aggregate. Then water absorbed by the coarse aggregate is equal to 1118.24 and 1112.68. The water absorbed by the coarse aggregate means some amount of water has been absorbed by the coarse aggregate, so we have to adjust that amount of water. That means we have to subtract the amount of water from the coarse aggregate. So by subtracting we have got 5.56 kg water has been absorbed by the coarse aggregate, and for fine aggregate it is 6.18 kg. So adjusted amount of the water now, so some of the water has been absorbed, so we have to readjust the water also. So the adjusted mass of the water is 191.58, that is the calculated, plus 5.56 plus 6.0 as per the formula, calculated mass plus the water absorbed by coarse aggregate oblique fine aggregate. So 203.32 kg per meter cube, and final mix calculation is given by. So we have got all the calculation, we have applied all the checks, we have applied all the adjustment, and we have followed all the steps. Then the final mix, that is we have got cement 445.53, it can be taken at 446 kg per meter cube, water 202.32, it can be taken as 203 kg per meter cube, fine aggregate to be taken as 618 kg per meter cube, that we have calculated, adjusted, we have calculated 618, coarse aggregate we have got 1112.68, we can take it 1113, and the water cement ratio is 0.43 that we have calculated. Now the cement is to find, and finally we have to find the ratio, that is the mix ratio, that is 1 is to 1.39 is to 2.5, for water cement ratio 0.43. we have got the mix design result. So throughout our lecture of today we have found that how to determine this mix proportion of the concrete. We have used no admixture, chemical or mineral, and we have find out the actual volumes, actual weights of the material to be used for 1 meter cube of concrete. That volume has to be used. So now depending on the volume to be used, we have to change this weights depending on the volume of the concrete that will be used in the site. So this is the process of the mix design. Okay, we have followed all the steps in the code, and we have done the procedure very much in easy way. So please go through the numerical, please go through the example and ask any question if possible, because mix design is, I have told you many times that it is the most important part of concrete technology. So throughout our lecture we have designed the mix for the problem given to us. In the next class, the next lecture, we will be designing another mix design of concrete with chemical as well as mineral admixture. We will be designing the concrete with chemical admixture as well as the mineral admixture. So all the checks will be applied here, and we will apply all the checks here, then the mix design will be some different. So this is the mix design that we have discussed. Okay, so please read it carefully and do the math by yourself, then we will get the actual knowledge, actual idea. Okay, so this is for today's class. We will see you in the next class. Okay, thank you students for your time.